Hello, I've got a fun example involving acceleration. If you'll take a moment to pause the video and copy all this information down. On the far right, I have our 5 equations of motion when we have constant acceleration. And then the situation on the left is you've got a person on a hill and you got a cart starting from rest and rolling down a hill and accelerating. So you can think of it as, oh my gosh, you're the parent at the top of the hill and you see your little kid start accelerating down the hill and you want to catch them and keep them safe. Okay, so if you need a second to pause the video and copy the example down and the equations, go ahead. All right. Now, so in this situation, I did not give you a distance, okay? So what I want to do is I'm going to give you a starting distance. So let's say that these two folks start off 25 meters apart, okay? Will the adult catch the kid? And if so, at what time do they catch them at? And how far have they each traveled if the adult catches them? Now, normally, if I'm in class, I would pause right now and I would give my students, I don't know, a good 4 or 5 minutes to give this a try and try this out. Now, if you want to do that, I strongly urge you to give that a shot and try it out yourself. I will go through a solution in a minute. A couple notes on this. One, you have to mathematically prove, okay, where and when the parent catches a child, or if the parent doesn't catch the child, same thing. You have to mathematically prove that. So I'll give you a moment. All right, so here's a solution, okay? So what I'm going to do is I'm going to use this fourth equation here, okay? And we have two objects, so I actually have to use two separate equations. So I'll call the adult, I'll call with P for a parent, and for the kid, I'll use a K for kid, okay? And I'm going to, instead of saying delta x, I'm going to actually write the position out. So I'm going to use this version of the equation. X final equals x naught plus v naught t plus 1/2 at squared. And what I'm going to do is I'm going to write that equation for both the parent and the kid. So there's going to be two separate equations because I got two objects moving. So for the parent, the final position equals x naught. Well, I'm going to call this 0 meters. That's the starting point for them. So it's 0 plus the whole time they're moving at 5 meters per second times some time that I don't know. And they're not accelerating. They have an a of 0. So this whole thing is 0. Okay. So that's the equation for the parent. So it's real simple. X final equals 5t. Okay. Now how about for the kid? Okay, so their equation looks a little different. X for the kid is equal to x naught. Well, they're starting 25 meters in front of the parents, so I'm going to put a 25 there, plus v naught t. Well, they started from rest, so they have a 0t, which is just plain old 0, plus 1/2. A is 1 for them, and then t squared. So for the kid, you have an equation that looks like 25 plus 1/2 t, okay, squared, sorry. Now, if the parent is to catch the child, what do we know? Well, if they meet, let's say, somewhere there, down the ramp somewhere, then their position has to be the same at that moment. Now, by the way, a big misconception is to say that the parent and the child must have the same velocity there. Well, that's not correct. The parent has to be going faster than the kid to catch them, okay? So, for instance, if you've ever been pulled over for speeding, let's say, don't tell mom and dad, in order for the policeman to catch you, they have to be going faster than you to catch you. And if you ever looked in the rearview mirror while they're doing that, you know that they are going faster than you to catch you. So same thing. The speeds of these two things, or the velocities of these two objects, will not be the same if the parent catches the child. They can't be. The parent has to be going faster than the kid. But what I do know is their positions will be the same. So I'm going to set these equal to each other. Okay. So we've got a 5t, that's the position of the parent. It's going to have to equal the kid's position. And you have this equation, and it's quadratic. Now, if I were solving this, I'm going to do two things. I'm going to double everything, and I'm going to move the 5t to the other side. So we end up with a t squared minus 10t plus 50 equals 0. Okay. Now I'm going to go ahead and write out the quadratic equation here. You can obviously do this in your calculator, but I like doing it on paper first to kind of notice something. So t equals the quadratic equation is b squared plus or minus. I'm sorry, negative b plus or minus b squared minus 4ac, all of that divided by 2a, right? So a is 1, b is negative 10, and c is 50. So we've got negative and negative 10. So we've got 10 plus or minus the square root of b squared, which is 100, minus 4 times a times c, all over 2a, which is simply 2. And so we get a time of 10 plus or minus the square root of negative 100 over 2. Well, you might notice a problem with this. You can't square root negative 100. Well, you can. You get an imaginary number, which means in the parent's imagination, they catch the kid, but in reality, the parent will not catch the child. So in this example, the parent does not catch the child, and oh, that's not good for the kid, right? All right, so now here's why I like to write all this out. What if we change the problem ever so slightly? What if I made this distance 10 meters? Okay, so how would that change our equations? Well, for the parent, it wouldn't change anything at all. This equation would be identical. In the kid equation, the only thing that would change, this would become a 10 instead of a 25. And so here in this over here, you'd have a 10. Okay, so if I set these equal, you'd have a 10 there. And then if I double that here, you'd have a 20. Okay, so in our quadratic equation, you'd have a 20 instead of a 50. Okay, and then this would now become square root of 100 minus 80, which is 20. Okay, and now with the quadratic equation, you have two solutions. And I believe if you plug your numbers into your calculator, I have these written down, you would get 2.76 seconds or 7.24 seconds. Okay, now what does that mean? Okay, why do we get 2 times? Well, what's going to happen is when the kid or when the parent catches the kid will be going AT, velocity of the kid, V final equals V naught plus AT. Now for the kid, V naught 0. So if you take 1 as A and T is your 2.76. So when the parent catches the kid somewhere here, assuming the parent doesn't actually grab the kid, the parent's going to actually pass the kid. But the kid's still accelerating. So at some point later on, and in this particular instance, that ends up being the 7.24 seconds, the kid would repass the parent. Okay, so that's why you see 2 times there. The parent would pass the kid, and then later on, the kid would pass the parent. Okay, and then you could figure out how far each object has gone. If we use the first time, let's say, you would just plug that in to these equations here. So for the adult, you get 5 times t, so whatever 5 times 2.76 is. And then for the kid, you would have 10 plus 1/2 times 2.76 squared. And that would tell you where each, well, that would actually, you would get the same answer for both those because they're at the same position. To figure out how far the kid went, you would then subtract 10 because you've gotten their position, but they've traveled 10 less meters than that because in the picture they had a 10-meter head start. Okay. All right. So I hope that example was helpful. And this is the kind of example we're going to see where I'm not going to give you a problem like, I mean, very few times will I give you a problem where there's just one object moving and it's just plugging and chugging numbers in an equation. You guys all did that last year. So this year we're going to add a little more fun to it. We're going to have multiple objects moving sometimes. We'll kind of find like things like when they meet, stuff like that, which require a little more than just plugging and chugging into one straightforward equation. So again, I hope that was helpful, and thank you very much.